Okay, so today we are going to be solving compound inequalities. Why they're compound is because I have two inequalities that are connected, and they're connected by an and or by or. There's going to be some words connecting your two inequalities, or your x is going to be like sandwiched in between two different signs. So steps for graphing: graph both statements above the line. If your problem is an and problem, the solution is the overlap. Think about like a sand which and is in the middle, an and inequality. Your solution's the overlap of that middle part. Or you're going to have an or inequality. In that case, it's this or that. It's both graphs. So here's an example. It says, and inequalities, both statements must be true and at the same time. So I have x is greater than negative 2. You could read that negative 2 is less than x, but we always start with our variable as we read. And I say x is greater than negative 2. And, meaning I want the overlap, x is less than 4. So on my number line, I want negative 2, I want negative 1, 0, 1, 2, 3, 4. Let me graph this one first. I'm going to graph x is greater than negative 2 first. I'm going to graph that in red. It's going to be an open circle, negative 2. And it says x is greater than negative 2. So I'm going to do a graph that says I want all the x's bigger than negative 2. Well, my next graph I'm going to make green, and that's and x is less than 4. So I have an open circle at 4. It says x is less than 4, so I want all the x's less than 4. For an and inequality to be true, both statements have to be true. Well, if I look over here, the red's not true. If I look over here, the green's not true. The only place they're true is this overlap. Meaning this overlap, this middle, is going to be my answer. So, my answer is all of this stuff in between. This whole yellow part is where my answer is. It's everything in that overlap between where they're both true. So my way of remembering it is I want to be big and strong. Think of it kind of like a dumbbell. You have your dot at one end, your dot at the other. You want all the stuff in the middle, big and strong. This is an and inequality. So let's look at this first one. It says x is greater than or equal to negative 3 and x is less than or equal to 0. So if I have negative 3, negative 2, negative 1, 0, 1, 2. If I graph this one first, x is greater than or equal to negative 3. I have a closed circle at negative 3. And I want all the x's bigger than negative 3. And, meaning I want the overlap. It's like that sandwich. X is less than or equal to 0. So I do a closed circle at 0. And now all the x's less than or equal to 0. Well, if I look at this side's not true. This side's not true because there's no purple over here. There's no blue over here. But this middle section, the overlap, is where I want to shade. The overlap is where my answer is. So all of your answers are anything in between -3 and 0. So it says, can I rewrite this as one statement? Well, if x can be anything between -3 and 0, couldn't I say that x is anything between -3 and 0? Couldn't I write it like this? Yeah, I actually could. And if you look at number 2, it's written just like that. This is saying x is greater than 5, and x is less than or equal to 12. So on my number line, if I have 5, 6, 7, 8, 9, 10, 11, 12, I can graph my green and my blue on the same graph. Let's start with the green. X is greater than 5, an open circle at 5. Everything bigger. And x is less than or equal to 12, so a closed circle on 12. Everything smaller. X is in the middle, so I want the stuff that's in the middle. I want this overlap. So your final answer is this shade right here, that middle shade. Everything in between 5 and 12. So this one says -1 is less than x, is less than or equal to x, which is less than or equal to 6. We're going to come back to these. Let's look at some OR inequalities. You're going to do that last slide for homework. Let's look at some OR inequalities. OR means if one is true, then the entire thing is true. So this or that, only one of them needs to work because they're going to be arrows facing in opposite directions. So my first one, x is less than or equal to 3. So if I make a number line, it goes 0, 1, 2, 3, 4, 5, 6, 7, 8. Well, if x is less than or equal to 3, I have a closed dot at 3, and now everything to the left of it. Or x is greater than 8. So I have an open circle at 8. I want everything bigger than that. So where's my answer? I got stuff over here and stuff over here. Your answer is actually both. Everything over here is an answer and everything up here is an answer. Usually with OR inequalities, you're going to have this middle space open. It's not going to be shaded like it is in the AND because you don't want the overlap. You want this or that. Kind of like this way or that way, your arrows are going to usually be in opposite directions. So I have -4 is greater than x. So I could also say x is less than -4. If I have -4 on my number line, if x is less than -4, I have an open circle at 4, or -4, and I'm going less than it. Or x is greater than 10. So if I do some tick marks, I have an open circle at 10. X is greater than 10, so I want all of the stuff over there, all of that shaded region. So what's my answer? Well, my answer is everything down here and everything up here. This way or that way. So I have x is less than 0. So if I come over to my graph, If x is less than 0, I have an open circle at 0. I want everything to the left. X is greater than or equal to 1. I have a closed circle at 1. And now everything to the right. So, you're getting the hang of it by now. What's my answer? Everything down here and everything up here. And I'm going to have this open space in the middle. So sometimes we must move things around to get our variables alone. Meaning sometimes it's not going to be all by itself like the past ones. So what do I need to do to get x alone? Well, right now, I actually have x sandwiched between two pieces. Well, I have 3x in the middle. If I'm trying to get x alone, I want to divide by 3. But if I divide by 3 in the middle, I have to divide by 3 in all of my pieces. So everything gets divided. Well, negative 9 divided by 3 gives me negative 3 is less than x, which is less than 4. Well, I can graph this. I can graph negative 3 is less than x, which is less than 4. If I have my number line, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. An open circle at negative 3. X is greater than negative 3, so I want all the stuff to the right. But then x is less than 4, so I have an open circle at 4, and I want all the stuff to the left. And we want that sandwich, we want the stuff in the middle, we want to be big and strong. So my final answer, what I shade, is this middle part, connecting my two dumbbells. Don't forget to flip the sign when you multiply or divide by a negative number. So with that being said, I have 1/2 times x is greater than or equal to 2. To get x alone, I want to multiply both sides by 2. That way those 2's cancel and I get 1x, or x all alone, is greater than or equal to 4. Or, if I divide both sides by negative 5, negative 25 divided by negative 5 is negative 5. But my sign flips because I divided by a negative to get x alone. So when I come to graph, I go negative 5, up to 4. Well, if I start down here at negative 5, x is less than negative 5. So I have an open circle at negative 5. I want everything to the left. Or x is greater than or equal to 4, so closed circle at 4, everything greater than or equal to it. So what's my final answer? Well, my final answer is everything smaller and everything larger than 4 and smaller than negative 5. So I want you to take some time and try these on your own. And we're going to come around and give you some help if you need it.